there are two teams who've been working on the kind of population and urban development part of this ARC analysis. So at Newcastle University is myself, Stuart Barr and James Virgo, and Nick Lomax and his team at Leeds University too. So we've essentially been trying to run through a two-stage modelling process to think about how these headline figures of 1 million homes or how many people that translates to would fit into the land available across the ARC local authority districts. So it's a two-stage process. The first stage is to simulate the demographic changes that may arise from infrastructure investments in those areas or housing developments. And the second stage is then thinking where would those developments translate into changes on the ground in terms of building of housing or employment sites. So we have two interlinked models here. We have the SIMIM model from the University of Leeds, which actually looks at the redistribution of the population across the ARC region. And then we have the urban development model at Newcastle that then thinks about where does the local scale development arise from those population changes. And the idea is that these then go on to drive in the demand for infrastructure services that Jim talked about in the first part of his presentation today. So we're essentially trying to go down scales here from the ARC as a region and a big set of numbers that may seem difficult to grasp or not tangible numbers, and then we're trying to go down through kind of population and household to actual physical dwellings on the ground and thinking about where those dwellings might go. So we can then think about the local demands on these various infrastructure types. So the work at Leeds has been producing results like these for the whole UK. So the Leeds University team have models of demographic change out into the future at small area scale right across the UK, including demographic characteristics like age and sex in the corner there. And these models are the kind of starting point for a lot of this analysis. But what we need to consider in something like the ARC is then the migration that is generated from transport interventions like the East-West Rail or the ARC Expressway. How does that play out in terms of additional movement of people across this area? So the model SIMIM that Nick Lomax and his team has developed tries to look at how those drivers, so where the jobs are located in the ARC and how accessible those jobs are by various modes of transport, would change the locations where people may desire to live. And the other key driver of this as well is the number of dwellings that are being constructed. As Jim mentioned earlier, there is some circularity in the story about which drives which. Does population demand drive dwelling construction, or does dwelling construction attract population change? And this is something that we're thinking through as we develop this analysis. So we've taken one route through at the moment, but it would be great today to discuss with the people in the room who know about these things how we should take this forward into the future. So the kinds of outputs that arise from this look like these maps here, where we've been playing with different scenarios and thinking about what do they mean in terms of how the population across the ARC region would change. And in some places this may go down as population is sucked into other areas by densification or concentration of jobs in different places. In some places it may go up. And these then provide the drivers that we can use to simulate the resulting land changes that come from these population scenarios. So sometimes we need to go down beyond just local authority district population numbers to a finer spatial scale. So this is where the urban development model comes in. So if we're thinking about drainage or flood risk or kind of impacts on natural capital, we need to think about where those people are located within that local authority, not just the total numbers of people in a local authority district. So UDM generates a detailed land use grid. We've been using 1 hectare grid squares to think about where this urban development may arise. And we use a spatial pattern of attractors and constraints that drive that development into certain locations. And we can go through this in much more detail this afternoon if you want to come and talk to us next door at our station. So we use a suitability surface that says these are the likely areas where housing will go under a population change of X number of people. This is how UDM works. And we end up with these kind of detailed spatial maps that Jim talked about before. So here are the suitability drivers that go into this model. and they look like this. And as Jim said, there are different patterns of suitability depending on the drivers we put in there. If we want to attract development to these 5 new settlements, or if we want to disperse it across expansion to existing urban areas, the patterns of suitability look different, and therefore the patterns where the new development is likely to go look different too. And the resulting patterns of development, as Jim's already shown, look something like this. So we can see for the expansion scenario, the existing centres grow, and the patterns of that growth are driven by these attractors, which are things like accessibility to public transport or the road network, and also a set of constraints, which are things like priority habitats or the greenbelt areas, depending on the scenario. And on the right-hand side, we have the new settlement scenario, where we see much larger kind of contiguous blobs that represent new settlements that take up a certain amount of land. The density that these are developed at is governed by the existing density in each local authority district. So we think, well, the characteristics of a local authority area will carry on into the future, but there's clearly a discussion to be had about densification and how this might play out. This is something we would like to simulate in UDM, and something we'd like to have conversations about today. As well as spatial maps, we can look at quantitative numerical values. So for each local authority district here, we have a development number in hectares for each of the baseline new settlements and expansion scenario. So you can see for Milton Keynes, for example, under the new settlements scenario, there's about 3,000 hectares of new development because it's the edge of one of these new settlement areas. But under the expansion scenario, there's probably double that amount of land because Milton Keynes attracts development as it's an existing urban area. Similarly, for central Bedfordshire, we can see similar changes to patterns under each of the 2 scenarios. And interestingly, for Oxford, we can see Oxford is very constrained if we use the constraints that we've set in place. In terms of Oxford City itself, there isn't much land left if we want to protect the things we want to protect. So again, there's a discussion there about densification. And this plays out in charts like this, where we can see Oxford, if we want to put the number of people that we've projected we want to put into Oxford, then we're talking about very high densities based on the available land. And again, this is where there are trade-offs between different decisions that we have to take. Another trade-off is whether we want to protect greenbelt or sacrifice greenbelt, and different scenarios have different constraints. And we can see the amount of greenbelt loss under these different scenarios may change drastically across the arc, again, based on presumptions about planning constraints. The final thing we're doing, just to point forward to some future work, is the downscaled simulations of urban form even further. So rather than having, as you see on the left in that kind of green area, just pixels that represent some urban development, we're thinking about how do we divide those up. And this is using some of the ideas that Tony Hargreaves, who's here today, developed of dividing those squares up, those 1 hectare squares, into more detailed urban form with buildings and green space and roads, and then starting to build kind of synthetic cities. And then this is to allow us to simulate surface water flooding or urban drainage capacity requirements for future development too. And I'll go into this more detail this afternoon if anybody wants to see the kinds of results. And this is where Nahid Mahajeri's work comes in as well, who's got one of these little leaflets. I would recommend you have a look through this, because how we actually generate these synthetic future cities is a really interesting piece of work that's ongoing too. So just to summarize, we're trying to understand the trade-offs across the arc from these different planning considerations that we have. We're not trying to recommend decisions with this pilot work. We're trying to provide evidence that might help to understand the implications of decisions. So we have these tools that we want to use, but we need the people in the room to help us understand what it is we should be modeling and how those decisions should play out through these tools. And we want to simulate options, not necessarily predicted outcomes in this case. All of this is underpinned by nationally available data, so it could be done anywhere. We're using the ARC as a proof of concept, but these models are designed to be transferable to other cities. And I'll finish there and hand over to Simon.